I'm Nate from Fusion Motor Company. Today we're going to do how-to TIG welding. So this is one of my favorite things to do. TIG welding is a high-skilled job. Takes a long time to get used to doing. It requires 2 hands and 1 foot. So you have 1 foot left over. So today we'll just do the basics. We'll get into the materials, we'll get into the parts needed, the machine needed, the safety equipment needed. And if you guys want to get anything deeper, just let us know in the comments and we can do another video on TIG welding. So first off, I'll start with the gear needed. So you need gloves. These are cheap Harbor Freight gloves, so they work fine. They're made for TIG welding, so they're thin. Your left hand, generally, if you're right-handed and you're using the torch, your left hand is receiving a lot of the heat, as you can see. Here's an old glove that's pretty funny. You can see how much the leather shrinks over time. This was a size large glove that, you know, it turns into nothing and you have to throw this away basically. I kept it because I thought it was funny how small the fingers got over time. And I don't know why I was still using it at that point. There's also something called the TIG finger. This can receive a lot of heat. So if you're running along a hot piece of metal, and if you need more protection than a thin glove would provide, this is a good way to go. They sell these in all different sizes and a bunch of different uses. So also other safety equipment needed is a hood. This is a necessity. You cannot look at TIG welding without a hood. If you do, your eyes won't last long. So it's actually pretty funny. It's kind of like the whole looking at the sun thing during the eclipse, where people just want to look and then afterwards they're like, I shouldn't have done that. So anytime someone's welding, someone looks over and they're like, oh, I just want to see how they're welding. And then afterwards you're like, oh, it immediately hurts. So I would definitely recommend a high quality hood. I wouldn't go with anything that's like super cheap, because this is your eyes. Your eyes don't grow back. It's something that needs to be protected. I use a 3M speed glass, has all the settings here. Depends on your preference, but I would always keep the shade up. I wouldn't run the shade super low, because then again, you're not protecting your eyes. There's other, depending if you're welding or grinding, you can do some different settings on there. But I love this hood. They have a new one out now. They're pretty pricey, but 3M makes nice stuff. Some of the other guys have Optrel. So Optrel is a really nice hood too. As you can see, these things have gotten a lot of use around here. Miller's also a nice hood. I have one of these at home. All of these work great. Any of those high quality brands, you're gonna be good. Your eyes will be protected, your skin will be protected around your face. Another thing that's always needed is long sleeves. You're gonna wanna wear, this is just what I was wearing today, so this isn't really welding attire. But with TIG, you're not getting those sparks coming off, but you still want something that's not gonna catch on fire. Additionally, you want long sleeves, you want gloves, because as you're welding, it's very similar to the sun. You're getting UV burns. So a lot of guys, they're welding in this area over time just becomes very leathery and hard, and it's not good. And they'll be like, oh, I don't get burned anymore. Still doesn't mean you're not having a problem. Later on in your life, you're probably gonna have skin cancer. Cover your arms, that's all I'd say. It's not worth it. Even if it's just a thin shirt, it's doing a lot for UV protection. I get it, it's hot. TIG welding is a lot like having your arms in an oven. You know, you're melting steel, you're melting aluminum. I get it, it's in the summertime, people don't want to wear long sleeves, they want to wear short sleeves, but it's not worth it. Wear long sleeves. In the long run, you'll be happier. Today we're welding with a Dynasty 350. This is a great welder. We have one of the smaller Dynasties, I think a 280. It's a little smaller, it's one we wheel around the shop more. We've had this thing for probably 10 years. This is a higher end welder. I don't know the list price off the top of my head, but I'd say above $10,000. So if you're just getting into welding, I wouldn't recommend going out and spending $10,000, $20,000 to get all your equipment just to get learning. I'd get with someone that already has a welder, learn how to weld that way, and then you can step into it. And there's some nicer, you know, Chinese welders on the market now that few $1,000s you can get into TIG welding. But it is a fairly expensive hobby to step into, or a career. You know, you need tools, you need equipment. It's expensive equipment. This one We can get into the settings later as we're welding, but I wanted to show you guys the basics before we start to weld. So you have the TIG torch, they call it. And basically the torch has coolant running through it to keep it cool. So if you have a water-cooled welder, which if you're doing any sort of high amperage welding or long runs, you're gonna want a water-cooled welder. They're a little more expensive, but they keep your hands cooler, and you'll really notice a difference in your hands. All right, so I'll get into the parts on the TIG torch. So here's our gas lens. So if we were welding aluminum or something where the argon coverage didn't matter as much, you could just run a normal collet body like this. I always prefer a gas lens. Even if I'm welding aluminum, I would just run a pink cup like this. And that can still go on a gas lens body. A lot nicer. A gas lens is really nice. It makes a big difference in the look of the weld. Also, you have a collet. The collet is the part that tightens down the tungsten as you tighten the back cap. So you have a back cap that's threaded, has an O-ring on it. And as you tighten this down, it pushes on that collet and it tightens the tungsten. Because that tungsten needs to be held in place. And the stick out, we can talk about more as we start welding. I'll just show you guys the parts here. And then these ferrite cups are really cool. There's a lot of different brands of these. These guys got pretty big in the welding community. A small company, they make really nice parts. This is a fairly large cup, as you can see the difference between, your argon that would be coming out of here, or whatever type gas you would be using. Typically TIG welding, you're using argon. There's some other materials that people use, but on 99% of the stuff that we weld, we can use argon. Here's like a full kit. You have your Pyrex cups. So these are very similar. These are made out of glass. They break a little bit easier. But any of these cups, one of the things I would say is your habit on where you set this down is so important if you don't want to just be replacing your cups every day. If you set this in a spot where it can fall down, even if I drop this from here, I could easily break a cup. So I'm always getting on the guys about that. Some of these bigger ones, you could spend $20 on something like this. So if every day you were breaking that, that'd be kind of a big deal. I think that covered that stuff, and all of this stuff just screws together. Fairly simple. I can get into showing you guys tungsten grinding. So I'll show you the old school way with just a grinder, where we hit this in a grinder. It's really important when we're doing this that we're not going perpendicular to the grinding belt. So if the grinding belt's running this way, we don't want to be going this way, because all of our marks are going to be going like that. We want everything to be shooting out of the tungsten. So we want to be spinning this at the same time and grinding it like this. And then if we zoomed in, we can do a shot later where I can show you guys the grind marks. This one I'll regrind, this is a used one. And you can see how all those lines are running towards the tip, because that's where we want the electricity to be coming out of. I always tell people that don't know about welding, it's kind of like a lightning bolt shooting out of there. We're melting metal with a lightning bolt that's shooting out of here. It's pretty cool when you think about it. It's not exactly lightning, but it's kind of like it. I'll show you guys a quick tungsten grind because I need to do that anyway. Safety glasses always when you're grinding, of course. You always want to be grinding away from your body too. The last thing you want is to be like this very sharp thing shoots into your body and stabs you. So it's important, I always go up here. And remember, if this belt is going this way, I'm grinding this way. I'm not grinding this way. So you can spin this by hand. It takes longer, way easier. Put it in your drill, tighten up the chuck. So I'll show you guys a little bit different angles here. Here's like a little more standard angle. A lot of the angles that come out of like a tungsten grinder, you could purchase a tool that actually does this where you don't have an open belt. Those are nice too. Some of them have adjustable angles on it. I always prefer a little more angle on it like this. I don't know why, I just like it better. On the back caps on the welder, There's one like this, like a mid-sized one. There's a little button one where if you need to get into a tighter area, you don't have that big part sticking off. And here's a full-size one. So obviously if you're running a full-size tungsten where you haven't broke it in half or grind it in half, and here's a half size. So some people prefer this. Me personally, I don't love the big long back cap on there. I like the mid-size one. Some people like it. It all depends. I mean, it'd be similar to someone drawing with a pen on paper. People hold the pen differently. People hold the welder differently. I usually hold this just the same way I would be if I was drawing. So the back cap doesn't matter that much. I just don't like having a lot of extra stuff hanging off to get in the way if I'm welding in a tight area. I'll run the mid-size cap with the half tungsten in this one. Some people also prefer to grind only a single side. A benefit of this is you still have the color on the back. On tungstens, there's many different types of tungsten, and you could be running a different type of tungsten to weld steel, a different type to weld aluminum. Some of them you could weld all of the materials with. So on this one, this is a purple tungsten, I think, on both of these. So if I remember right, we can weld any material with that. But usually they specify when you buy it, so you can just make sure you have the right tungsten for the right material that you're welding. Personally, if I'm running a big cup, I prefer stick out about like this. These cups are amazing where you could have like a pretty far stick out. Those are the type scenarios where you would be in here, and as you could see, my cup would be hitting before my tungsten. So you need to stick out about like this if you're running a large cup, unless you want to drastically change your angle. All right, so on our initial settings, amperage is your main setting. And that's basically how much power you have going into the welders, or coming out of the welder, I should say. So 160 amps, we could weld on that today. I think I have 3/16 plate there. I might actually step that up. Maybe I'll do 180. This is just a test to show you guys how to weld, so don't get too caught up on the settings. Every machine's settings are going to be a little bit different. So if I even went to the 280 welder and I was welding somewhere else, the settings might be slightly different. So a lot of times people get caught up on settings, but don't get too caught up on that. A lot of times doing a test weld first is the way to go. So a big one is amperage, and then AC and DC. If you're welding steel, stainless steel, you're on DC. If you're welding aluminum, you're on AC. That's direct current or alternating current. That would be similar to like a house coming out of this cord, a house, you're running AC, and in a car, you're running DC. So those are just two different types. You have to do that. It literally won't work if you don't put that setting correctly. Another big one is the pulse setting. I'll show you guys this later, but you could turn on how many pulses per second, all the way up to a ridiculous amount, to 5,000 per second. And if I went down here and I went to 2, that means that every second it would pulse twice. So bop, bop. And that's a different type of welding, but I'll get into that more later. These settings are more for aluminum. Pre-flow, post-flow is another big one. Our post-flow, let's go to 10 seconds. So post-flow is how long the argon is going to stay on after you weld. That's important if you want to have those pretty colors. Very important to have the post-flow set correctly, or you can tap the pedal, and I'll show you guys that too. So we're set amperage 180 on DC. I haven't welded in a few months. After tearing my Achilles, I still don't have the motion in my right foot. These pedals have a little more throw than a car gas pedal. I can drive with this amount of motion, but I can't press the pedal all the way down. Doesn't really make a difference. If you've welded thousands of hours, you've probably welded with both feet before. You've probably welded with your knee, your elbow, anything that you could get on the pedal, because you get in those weird scenarios where you need to do that. So on this, I'm just doing some little test strips here. This is just mild steel. 1, 2, 3 block if you want to set up to tack your welds. It's always good to build something square. Even if I'm doing a test strip, I usually throw a 1, 2, 3 block on here. And I'll show you tacking first. So tacking is very important. That's just your initial part. You're not going to have a piece like this and just weld the whole thing without tacking each end. The part would be all out of shape by the time you were to the end. So it's really important to put tacks on it. And there's more strategic ones, but I'll just get into basic, just how to tack. With tacking, you want to get in and out fast. You don't want to be sitting there. You're not welding. You're just sticking the part so that you can weld it. You'll see a lot of times when people first get into welding, they tack way too slow, where they're sitting in it, they're building a bunch of heat, or they build a tack that's way larger than it needs to be. So with this, I won't even use rod, and I'll actually show you guys fusing also. So I guess really we'll show 4 types of welding in this. So on a tack, and sorry, this is going to be bright a little bit. You want to get your tungsten as close as possible to the metal without dipping it in the metal. Once you dip this, you need to regrind. So less than a second, you're in, and you can see how that lifted this other side. And that's, obviously I can just press that back down and re-tack this side. You can get in and out fast on that. And you can see I have a nice tack. Obviously the post flow is excessive for a tack, but I'm about to weld, so I wanted that setting already in there. So this is 1/16 filler rod, so in other words 1/16 of an inch. This is pretty standard for doing plates and stuff like this. You obviously have your thinner filler rod, and this would be more for doing like sheet metal. So what's happening when you're welding, you are melting these 2 pieces of metal together, and then of course that's going to form a crater. You're filling it in with the filler material. So using the correct filler metal is also important. This is ER70. This is like your pretty standard, just mild steel that you would use ER70 for. There's all different types of filler rods depending on what type of material you're welding. So nothing special. This is my first weld in 2 months. That was a continuously down. I went all the way down on the pedal and held it there. I could probably show you on the machine when I show you foot pulse. It all depends on the industry, what you're doing. If you're doing aerospace welding, they're not going to be foot pulsing. If you're in the trophy truck world, they're going to double pass. They're going to probably do a continuous on this, and then they're going to foot pulse the second pass. It all depends on what you're welding. I'm just getting into the basics, so I'm sure there's going to be people that are going to be like, I do this and I do that, but these are basics. So we can get further in on another video on some details, but I don't want to go too far and then have like an 8-hour video here. So you can see the heat on the back. This isn't running super hot for the thickness of the material. If you were going to weld this side also, you would want to clean this. You see where this starts popping through like this? This is going to get dirty in your weld. This is carbon that comes out of the material as you heat it. So you want to have a nice gold weld. I could have stayed on there a little longer. The color of the metal is all based on when you remove the argon from the metal. So depending on the type of metal, if it's stainless or if it's steel, this is just mild steel. You can still get nice gold color from mild steel. But if I remove that argon, immediately, this is going to turn gray. It's going to be ugly. It's not as good of a weld. If you keep it on there until it cools to a certain temperature, I don't have that chart in front of me, nor would it really matter because I'm not holding a thermometer on there while I'm welding. It's more of a looks thing, it's more of a feel thing, and you really get a hang of what you're welding and how long you need to hold the argon on for. Additionally, when you're welding, this big cup helps because you can see this is the surface area that the argon's covering. So as I move, it's really keeping that in that area. It also helps that this is a 90-degree surface here. This helps keep the argon in. If I'm running an outside corner like this, you could imagine as I'm welding, the argon's flowing off of the part and it's not staying in the part. If you want to keep nice color on this, get an aluminum block, put it on here, and you could see now you're building that wall for the argon to stay covered. Otherwise, that argon's gonna fly away. Your weld's probably gonna be gray on an outside corner if you don't use some heat sinks on it. So I'll show you a pulse weld also. We can go back and weld the backside on this later. I can show, I'll show a foot pulse for half of this, and then I'll show a machine pulse and how much different they are. So I'll just tack these real quick first. So that way you can see I moved slower. I put a lot more heat into it. I didn't keep it on as long, and you can see the color difference here. You can see how big the color difference is if you pull that gas away sooner. So here we're gonna do pulse. So this pulses per second, 1.8. Or actually, you know what, I'll go to 2. And then the amperage does change on this machine when you do the pulse, so I'm gonna move this back up. So on this one, before I'm pumping my pedal manually, I'm moving my foot. This one, the machine's gonna do it for me. So every 2 seconds, or every second, it's gonna be pulsing twice. Machine pulse, the one nice thing about using machine pulse, I wouldn't do it on a root pass like that, but I'm just showing you guys the different features on it. I can go over this with a cap and I can show you guys how nice and pretty that looks. One of the benefits of that is this width that happens here is very consistent because the machine is doing the exact same amperage every time. Of course, you can let up on the pedal and the amperage will be less, but if you were all the way to the floor, this should remain the same throughout the whole weld. If you're doing a really long pass, as the part heats up, sometimes this can grow. So you could end up with a weld that started small and then got larger towards the end because the metal is melting easier. If that's happening to you, that's something that with experience you see it as it's happening and you correct with your foot. And you would use less input on your foot for that to happen. I'll show you guys a quick pass over this. It's still a little bit warm, but sometimes you can get a really beautiful, and this is a lot of times what people do when they go for pretty welds. They're running a root pass and then they're capping it with a pulse weld. This part was already warm from the first weld, so you can see the color changes throughout because the part was already warm going into it, so it's difficult to keep it cool. But yeah, you can see the consistency when you do a machine pulse. Some people hate machine pulse and they use all foot. Nothing wrong with either if you're gonna pulse weld. Some people say the machine is cheating, but you're using a machine, so I don't see how it's cheating. Depends on the application. I could do either. You do always have control if you're using your foot pulse, so some people like that control. If you're just starting out, I wanted to show you guys just a fuse weld one time. So if you were just starting out, I would say put this one away because you're already using a hand, a foot. All of them are strange to get used to. So I would take one out of the mix. Obviously, this isn't like a real weld. This is just something to practice to get used to welding in general, if you're starting out TIG welding. And I would just have you draw basically with the welder. So if you're welding thin material, like an exhaust that's only a 1/16 of an inch thick, you could very easily fuse that together with very, very minimal undercut where you don't even see that. If you have a perfect fit up, and it's something that you could actually learn to weld with, but in general, thick plates, you're never going to fuse them together. That's ridiculous. This is more of a test or something to practice. Your edge control to be correct. So you always want that to be a consistent width. And this way your left hand's not doing anything. And then once you master this, add in the rod. And with each dab, you're dipping the rod. And you always want to be removing this from the heat also so that it's not just blobbing in on its own. If I'm moving like this, I'm going to move and I'm going to dip and I'm going to move it back. So each time I move, I'm going to be dipping. And then additionally on that, I was pulsing, so my foot's working in unison with that. A lot of times guys like to listen to music. It's funny, if you listen to the right kind of music, it can be beneficial. The only problem is you can't hear what's going on, if anything's popping, if anything's doing anything weird, but you can get a good rhythm going. So a lot of guys that TIG weld all day, they already have it down. They don't need their ears to work, but they can get the rhythm going. It's nice to listen to music while you're doing it. So I hope that helped. If you're new to TIG welding, it's a lot of information to take in. This is a high skill job. This isn't something that you're gonna learn in a day. I have thousands of hours of welding, and you can always learn new things still. Thanks for watching the video. If you guys have anything else that you want me to cover on TIG welding or in general on car building, TIG welding is just one of the many skills that it takes to build a whole car. I became obsessed with the idea of learning all of those things. Besides paint and body, I can't handle the chemicals. So the clean stuff like this is my favorite, the design stuff. But I would say if there's anything else you guys want to get into with welding or anything I missed or any specifics, let us know. We'll do more videos for you guys. Thanks for watching.